Hello students and good afternoon. So now I am doing class for class 12. This is the continuation class. In the last online class we were doing the chapter standard integrals. So today also we will continue the same chapter, that is standard integrals. Same exercise 6b, page number 362, section 2 mark section from the book Higher Mathematics for Class 12 by Sailendra. And in the last online class we did question number 4, and now we will do question number 5. So you have to find out the value of this integration, that is integral of x square dx divided by 9 minus x to the power 6. So how will you do it? So now this is I is equal to integral sine x square dx divided by 9 minus x to the power 6. So for this question you cannot directly use standard integral. So first of all you should know the method of substitution also. You should have the knowledge of method of substitution in this case. In the numerator we have x square and in the denominator we have 9 minus x to the power 6. Now differentiation of which function is x square? X cube, isn't it? What is the differentiation of x cube? 3x square. 3 is constant here, but we are getting this x square, isn't it? So let us make it x to the power 6 as x cube whole square, and 9 can be written as 3 whole square. So or I is equal to integral sine x square dx divided by this is 3 whole square minus this is x cube whole square. Is that clear? So now first of all we have to use the method of substitution. So let us put z is equal to x cube, so that this differentiation is 3x square. Okay, so let z is equal to x cube. So differentiating both the sides, with respect to x. So it is dz by dx is equal to 3x square. Now cross multiply. What is dz is equal to? It is 3x square dx. Is that clear? But in the numerator we have only x square dx. You have to get the value for x square dx from here. That is, let us take this 3 to the left hand side, or dz upon 3 is equal to what? It is x square dx. It is x square dx. So x square dx is dz upon 3. Okay. So let us put these values in I. So therefore I is equal to integration of what is x square dx? It is dz upon 3. It is dz upon 3 divided by, it is 3 whole square minus, what is x cube? It is z square. It is z square. Okay, so or I is equal to, now which is constant here? 1 upon 3. Let us take it outside integral sign. 1 upon 3 integration of dz divided by, this is 3 whole square minus z square. Now in this case, which standard form is this one? This is 3 whole square minus z square. Here the value for a is 3 and x is z. Here the value for a is 3 and x is z. So which standard form is this one? This is the third standard form, that is integration of dx upon a square minus x square, whose formula is 1 upon twice a log within mod a plus x upon a minus x. The base is e plus c. So let us write here, or I is equal to 1 upon 3 constant, you have to write it, into 1 upon 2a. 1 upon 2 into what is a? 3 log within mod a plus x, that is 3 plus z divided by a minus x, 3 minus z plus c. A minus x means 3 minus z, a plus x means 3 plus z. And what is the base here? The base is e. or I is equal to, let us simplify it, 1 upon 3 2s are 6, 3s are 18. So it is log within mod 3 plus, what is it, x cube, 3 plus, here z is x cube, divided by 3 minus x cube, mod sign closed, the base is e and plus c. So this is the final answer. So I hope you have understood it. So you can copy it. Now we will do the next problem. So now we'll do the next question, that is question number 6. You have to integrate integral sign dx divided by root over x within bracket 4x minus 49. So now in this case, within square root there is x. You have to remove this square root. Okay, so you have to put x is equal to z square in this case. Okay, if you put x is equal to z square, square root will be removed. So first of all, let us write I is equal to integral sign dx divided by root over x within bracket 4x minus 49. Okay, so let us put x is equal to z square. Let x is equal to z square. So let us write differentiating both the sides with respect to z. Therefore dx by dz is equal to 2z, or dx is equal to, what is here, it is 2z dz. So we have got the value for dx, right? So let us put these values in I. So therefore I is equal to integration of, what is dx, 2z dz, it is 2z dz divided by root over z square, it is root over z square, and within bracket 4, and what is x here, it is z square and minus 49, and this is minus 49. Okay, so which is constant here that you can take outside, to integration of, now it is z dz, now it is z dz divided by, what is square root of z square, it is z. So within bracket we have 4z square minus 49, it is 4z square minus 49. So here you can cancel this z, or I is equal to, now what will you do in the next step? I already told you that whenever you have coefficient, always make the coefficient of x square or z square 1. Okay, then only you can convert into a standard form. So in order to convert this expression into a standard form, always make the coefficient of x square or z square 1. Okay, so it is 2 integration of dz divided by, what is common here, 4. So it is z square minus 49 upon 4, right? So here 2 1s are 2, 2 2s are 4. So which is constant here, again you can take outside, it is half integration of dz divided by, so let us convert them into standard form. So it is z square minus 7 upon 2 whole square. Is that clear? Now this is a standard form. Instead of x there is z, instead of a there is 7 by 2. So which standard form is this one? This is the second standard form, which is 1 by twice a log within mod x minus a upon x plus a. So or I is equal to, this is half into 1 upon 2 into a. This half is constant, you have to write it. Now use the formula into 1 by 2 into, what is a, 7 by 2 log within mod in the numerator x minus a divided by in the denominator x plus a, right? Then write down plus c. So now here you can cancel this 2 gets cancels, or I is equal to 1 upon 14, right? So log within mod, you can simplify it. In both the numerator and the denominator, what's the LCM? 2 is the LCM. You can cancel them. So after simplification, you'll get 2z minus 7 divided by 2z plus 7 mod sign closed plus c. Okay, so let us put the value for z here, or I is equal to 1 upon 14 log within mod. You can write down the base here, base is e, base is e, base is e. So 2 into, what was z actually? Actually x is equal to z square, and what is the value for z? Z is equal to root x. So z is root x. It is root over x minus 7 divided by 2 root over x plus 7 mod sign closed plus c. So this is the final answer. So I think you have understood it, so you can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 7. So let's do this question now, that is integration of dx divided by x root under x plus 1. Okay, so let us write here I is equal to integration of dx divided by x root over x plus 1. Okay, now in this case also you have to do the method of substitution first. You cannot directly use your standard integrals. So here directly we cannot use standard integral. First of all, you have to do the method of substitution. So let us remove this square root by putting x plus 1 is equal to z square. So let x plus 1 is equal to z square. If we put x plus 1 is equal to z square, it will be root over z square is equal to z. Okay, so let us differentiate both the sides with respect to z. So differentiating both the sides with respect to z. So therefore dx by dz is equal to 2z, or dx is equal to 2z dz. So it is dx is equal to 2z dz. Okay, so now let us put these values in I. So therefore I is equal to integration of, what is the value for dx? It is 2z dz. It is 2z dz divided by, now there is x only, you have to put the value for x here. So x is equal to, what is x here? It is x is equal to z square minus 1. From here, what is the value for x? It is z square minus 1. So we can put x here, that is z square minus 1. Z square minus 1 into within root z square. Here within root there is z square. Is that understood now? So in the next step, we can take this constant to outside integration sign. So I is equal to 2 integral sign. So it is z dz divided by, in the denominator, z square minus 1. It is z square minus 1 into, what is root over z square? It is z. So here z will be cancelled, right? So or I is equal to 2 integral sign dz divided by, this is z square minus 1 is also 1 whole square. Now this is the standard form. So instead of x there is z, and instead of a there is 1. This is the second standard integral, that is integration of dx divided by x square minus a square, which is 1 by twice a into log of x minus a upon x plus a. So or I is equal to 2 into, it is 1 upon 2 into A is 1 log within mod x minus a, z minus 1. X minus a is here, z minus 1 divided by x plus a, z plus 1, then plus c. So here 2 gets cancels. Or I is equal to, this is 1 by 1 is 1, you don't have to write it. So it is log, you can write here base e within mod, what is the value for z? Here the value for, if z square is equal to x plus 1, what is the value for z? It is root over x plus 1. It is root over x plus 1 minus 1 divided by, in the denominator, root over x plus 1 plus 1, then plus c. So this is the final answer. So I think you have understood it. So you can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 8. You have to integrate integral sign dx upon e to the power x plus e to the power minus x. So let us write here I is equal to, so I is equal to integral sign dx upon e to the power x plus e to the power minus x. Okay. Now here e to the power minus x, you can simplify it further. E to the power minus x can be written as 1 upon e to the power x. Let us simplify it first, okay? So I is equal to, this question is very important. You can mark it. So I is equal to integral sign dx divided by e to the power x plus, this is 1 upon e to the power x. Okay? So now let's take the LCM. Or I is equal to integration of dx divided by, what's the LCM? It is e to the power x. In the denominator, what's the LCM? E to the power x. So e to the power x into e to the power x, if you multiply them, powers will be added. So it is e to the power 2x, then we can write here plus 1. So now after simplification, e to the power x goes up in the numerator. Or I is equal to integration of, this is e to the power x dx divided by e to the power 2x plus 1. Is that understood? So now in this case we can use the method of substitution now. Now in the denominator we have e to the power x. Now differentiation of which function is e to the power x? E to the power x, isn't it? Differentiation of e to the power x is e to the power x. Now in the denominator, this e to the power 2x can be written as e to the power x whole square. So or I is equal to integration of e to the power x dx divided by e to the power x whole square plus 1. Okay. So now we can assume, let z is equal to e to the power x. Let z is equal to e to the power x. So now it is differentiating both the sides. Differentiating both the sides with respect to x. Okay. So therefore dz by dx is equal to e to the power x. Now cross multiply. Or what is dz is equal to e to the power x dx. So we have got the value of the numerator, that is e to the power x dx is dz. So therefore I is equal to integration of, what is e to the power x dx? It is dz divided by, in the denominator, what is e to the power x whole square? It is z square plus 1 can be written as 1 whole square. Now this is the standard integral. That is, instead of x there is z, instead of a there is 1. This is the first standard integral. So what is the formula for the first standard integral? It is 1 upon a tan inverse x upon a. So it is I is equal to 1 upon A is 1 here. Then tan inverse x by A. So it is tan inverse, what is x by A? Z by 1. Then you have to write plus C. Okay. Now you can put the value for Z. So or I is equal to tan inverse within bracket. 1 upon 1 is 1. You don't have to write that 1. So what is the value for Z in this case? It is e to the power x. So it is e to the power x bracket closed plus C. So this is the final answer. So this question is very, very important. You can mark it. Okay. So now let's do the next question now. So now we'll do the next question, that is question number 9. You have to evaluate this integration. So it is integration of dx divided by root over x plus x root over x. So therefore I is equal to integration of dx divided by root over x plus x root over x. Okay. So what will you do here? Let us take out common. What is common here? Root over x. Or I is equal to integration of dx divided by root over x is taken common. So within bracket we have 1 plus x. Okay. So now let us do the method of substitution in this case. Let us remove a square root from x. So let us put x is equal to z square. So let x is equal to z square. So let us write here differentiating both the sides with respect to z. So therefore dx by dz is equal to 2z. Okay. Or dx is equal to, this is 2z dz. So we have got the value for dx, which is equal to 2z dz. Okay. So now let us put these values in I. So therefore I is equal to integration of, what is the value for dx? It is 2z dz. It is 2z dz divided by, in the denominator, root over z square, isn't it? Root over x means root over z square. Root over z square. And within bracket 1 plus x is z square. So it is 1 plus z square. Is that understood now? So let us simplify it further. Or I is equal to, here 2 is constant taken outside. Integral sign. This is z dz divided by, what is root over z square? That is z. And within bracket 1 plus z square. So here z gets cancels. Or I is equal to 2 integral sign dz divided by 1 square plus z square. Is that clear to all of you? So here a is 1. This is the standard form number 1. Here x is z and a is 1. This is the first standard form. So what is the formula in this case? So I is equal to 2 is constant. You have to write it into 1 upon a. That means 1 upon 1. And tan inverse x upon a. That is z upon 1. Then you have to write plus c. So I hope you have understood it. So let us put the value for z. What is the value for z from here? Here the value for z is root over x, isn't it? If z square is equal to x, then z is root over x. Or I is equal to, or this is I is equal to 2 tan inverse, what is z? It is root over x. Bracket closed plus c. So this is the final answer. So I think you have understood it. So you can copy it. Now we'll do the next question. So now we'll do the next question, that is you have to evaluate this integral. That is question number 10. Integration of dx divided by root over 16x square plus 25. Now the denominator is within square root. Now in this case you have to use standard integrals number 4, 5 and 6. That is you have to use 4th standard form or 5th standard form or 6th standard form. So let us write here I is equal to integral sine dx divided by root over 16x square plus 25. Okay, so what is the method here? Here also you have to make the coefficient of x square 1. Here also you have to make the coefficient of x square 1. That means you have to take 16 as common here. Or you may use different method here also. Let us write it within whole square. 16x square, that is 4x whole square. And what is 25? It is 5 whole square. But don't use the formula because the coefficient of x within whole square is 4. And let us assume this 4x as z so that we can use the standard form, right? So, or I is equal to integral sine, this is dx divided by root over, this is your 4x whole square plus this is 5 whole square. But you can't use the standard form here because here within whole square the coefficient of x is 4. Within whole square the coefficient of x is 4 here, so we cannot use directly the standard form out here. So let us assume this 4x as z. So let z is equal to 4x. Okay. So differentiating both the sides. Differentiating both the sides with respect to x. So it is dz by dx is equal to 4. Now cross multiply, dz is equal to 4 dx. Now let us get the value for dx. That is dz upon 4 is equal to what? It is dx. So what is the value for dx in this case? It is dz upon 4. Is that clear? Next, what is I? So now I becomes here, I is equal to, what is the value for dx? It is dz upon 4. It is dz upon 4 divided by, dx is dz by 4 divided by root over z square. Root over z square plus, then it is 5 whole square. Then it is 5 whole square. Is that clear? So which constant is here that is taken outside? I is equal to 1/4 integration of dz divided by root over z square plus 5 square. Now which standard form is this one? Instead of x there is z, instead of a there is 5, but both the expressions are within square root. So this is the 4th standard form. So or I is equal to 1/4. What is the formula? Log within mod. What is x here? X is z plus root over what is x square plus a square? It is z square plus 5 square. Mod sign closed. The base is e and this is plus c. So let us put the value for z now. What is the value for z? It is 4x, right? Or I is equal to 1/4 log within mod. What is the value for z? 4x. It is 4x plus root over, this is your 4x whole square plus 5 square, mod sign closed. The base is plus, what is the base? Base is e. Log within mod, what is the value for z? 4x plus root within root. What is z whole square? 4x whole square plus 5 square, mod sign closed. The base is e and plus c, right? So let us simplify it further. I is equal to 1/4 log within mod 4x plus, it is within square root. What is 4x square? 16x square plus what is 5 square? 25, mod sign closed. The base is e and this is plus c. So this is the final answer. So I think you have understood it. So you can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 11. You have to evaluate the integration of, that is integral sine dx divided by within root 3x square minus 5. So let us write here I is equal to integral sine dx divided by root over 3x square minus 5. So here either you can take common as 3 because you have to make the coefficient of x square 1, or you may write within whole square root over 3 into x whole square minus root 5 whole square. Then you have to assume z is equal to root over 3 into x. Okay, or you may take common here as 3 to make the coefficient of x square 1. Okay, or you can write it within whole square also, root over 3x whole square. So let us write it here. I is equal to integral sine dx divided by within square root, this is root over 3 into x whole square, isn't it? This 3x square is kept within whole square, that is root over 3 into x whole square, and it is minus root over 5 whole square. Is that clear? But we cannot use standard form in this case because before x within whole square there is root 3. Coefficient of x within whole square is root over 3. So let us assume it as z. So let z is equal to root over 3 into x. So let us write here differentiating both the sides with respect to x. So therefore dz by dx is equal to root 3. Okay, cross multiply. So dz is equal to root over 3 into dx, and root 3 is taken to the left hand side. So dz by root over 3 is equal to dx. That is, root 3 is taken to the left hand side, so it goes to the denominator. So it is dz by root over 3 is equal to dx. So I think you have understood it. So let us put these values in I. So therefore I is equal to integration of, what is dx? It is dz by root 3. It is dz upon root 3 divided by, it is root over, what is root 3 into x? It is z square. It is z square minus root 5 whole square. It is root over 5 whole square. Okay. Now which is constant here that you can take outside? Or I is equal to 1 upon root 3 integration of dz divided by root over z square minus root over 5 whole square. Is that understood now? So in this case here, instead of x there is z, instead of a there is root over 5, but both are within square root. So this is standard form number 5, that is integration of dx divided by root over x square minus a square. So let us use the formula. Or I is equal to 1 by root 3 is constant log within mod x plus root over x square minus a whole square, mod sign closed, base is e, then plus c. Okay, so let us put the value of z. Or I is equal to 1 upon root 3 log within mod, what is the value of z? Here z is root over 3 into x. Z is root over 3 into x plus root over, what is z whole square? Root over 3x whole square. Root over 3x whole square minus root over 5 whole square is 5. Mod sign closed plus c. Okay. So here the base is e. Right. So or I is equal to, this is 1 upon root 3 log within mod, what do we write? Root 3x plus root over, what is here? What is root 3x whole square? Root over 3 whole square is 3. This is x square minus 5. Mod sign closed. The base is e plus c. So this is the final answer. So I think I've understood it. So you can copy it. Now we'll do the next question, that is question number 12. So now we'll do the next question, that is question number 12. That is integral of dx divided by within square root 49 minus 9x squared. So let us evaluate this integration, right? So therefore I is equal to integration of dx divided by root over 49 minus 9x squared. So here also we can use the same method as we have done in the previous problem. So let us write it as, we can write it as 7 whole square minus 3x whole square, and 3x can be assumed as z in order to convert into standard form. Or you may use different methods. Let us make the coefficient of x square 1 in this case. Let us use different methods in this case, isn't it? Okay. That is, in this case, let us use different methods in this case. Okay. Let us use different methods. That is, let us make the coefficient of x square 1. That means you have to take common as 9, isn't it? So let us take 9 as common. So integral sign dx divided by within square root. Let us make this coefficient of x square 1. That means you have to take 9 as common. So within bracket we have 49 upon 9 minus this is your x square. Is that understood now? What is square root of 9? You can take it outside. 1/3, it is constant. It is taken outside integral sign 1/3. So it is dx divided by within square root. Let us write this 49 by 9 in terms of whole square. That is 7 upon 3 whole square minus x square. Is that understood now? So now this is the standard form. So which standard form is this one? That is root over, instead of a there is 7 by 3 which is constant, and instead of x there is x. So this is the sixth standard form. That is integral sign dx upon root over a square minus x square, whose formula is sine inverse x upon a. So let us write down the formula here. So or I is equal to 1/3 is constant, you have to write it, into. So what is the formula for this standard integral? Instead of a there is 7 by 3, and instead of x there is x. So what is the formula? It is sine inverse x upon, what is a? It is 7 by 3. It is 7 by 3 bracket close plus c, right? So or I is equal to, this is 1/3. This is your sine inverse within bracket. It is 3x by 7. So 7 by 3, when it goes up in the numerator, it becomes upside down. That is 3 by 7. So it is 3x by 7 plus c. So this is the final answer. So I think you have understood this question. So you can copy it. So this much is for today. त आज पनि हामीले जति पनि प्रब्लम्स गर्यौं सबै स्ट्यान्डर्ड इन्टिग्रल्स को एप्लिकेसनहरु हो। यो सबै नै तिमीले घरमा रिभिजन गर्नु, फर्मुला राम्रोसँग याद गर्नु। So in the next online class we will do more problems on these standard integrals. So this much is for today.